Hello dear students, how are you all? Welcome to the YouTube channel of AB School Partapur. I hope all of you are doing fine. Before we begin, let me tell you, please subscribe to our YouTube channel so that you can get notifications as and when we upload a fresh new video. Like and share our videos so that your friends even can be benefited in this difficult time. In the last lecture, we talked about modern periodic table. Did you like that methods to remember modern periodic table? Totally 118 elements we remembered, which is actually a very big task. If you ask me, even the students of college find it difficult to remember the entire periodic table. But if you could memorize the periodic table, then it is definitely a big achievement. This will be helpful to you even in further standards, 11th, 12th, as well as in college. In the last lecture, I told you to make a chart of the modern periodic table. Hopefully, all of you have made the chart and have applied that chart on the place where you read. So, once you are done with that, you can continue with the video. So, in this chapter, today we are going to talk about just the basic introduction and the earlier methods of classification. So, first of all, in last standard, that is in ninth standard, all of you have studied that substances can be classified into three parts, namely elements, compounds, and mixture. Do you remember what is meant by elements? Elements are the substances which contain only one type of atoms. Compounds, on the other hand, contain two or more type of atoms. These atoms are attached to each other in fixed proportions with the help of some chemical bond. Last but not the least was mixture. Mixture contains two or more substances. These substances can be either elements or even compounds. But the difference between compound and mixture is the substances present in the mixture, they are not attached to each other by any chemical bond, as well as their proportion is not fixed. While in compound, you will find that two or more elements will be attached in fixed proportion. But likewise here, no fixed proportion we can say. So in this chapter, we are going to talk about the elements which are found up till now. Because of human efforts and endeavor, up till now we have discovered 118 elements. Out of these 118 elements, only 94 elements are naturally occurring elements, while remaining elements are developed in laboratories. Now you can understand that to study 118 elements and their properties would be a Himalayan task. Definitely, it would require a lot of time to study the properties of 118 elements. So scientists tried to find out some pattern when it comes to the chemical properties of elements. And they thought of grouping the elements so that the study of chemistry could become easy. Different efforts were made by scientists to classify elements so that we could bring about some order from chaos. Making order out of chaos. Let us talk about the early attempts made by different scientists in order to classify elements. As you know, we always like classification and orderliness. Imagine each and every person out of us know hundreds of people. Say for example, you save their contact details in your mobile phone. Hundreds of people. It's very difficult if all these numbers are stored haphazardly. Therefore, you know that in your mobile phone or in your contact diary, all the names will be shown alphabetically. So that is one way of classifying names and contact details. Just like that, in earlier times, as we know that 118 elements, and to study all these elements separately, it would not be possible practically. Therefore, we tried to classify elements. Earlier efforts made by humankind classified elements into roughly two parts based on their properties, which are metals and non-metals. Elements which has the property of donating electrons were called metals, and elements which had the property of gaining electrons were called non-metals. But this classification would not be sufficient because in later parts, as you know, we came to know about 118 elements. So therefore, different efforts were made by different scientists time and time again to classify elements and to make the study of chemistry easy. The first ever notable attempt was made by a German chemist named Döbereiner. The another attempt was made by a scientist named Newlands. Another notable effort was made by a Russian chemist called Mendeleev. You might have heard this name in the modern periodic table. Yes, there is an element called Mendelevium, which is named on this Russian chemist Mendeleev. And last but not the least was Henry Moseley, who gave us modern periodic table. The law given by Döbereiner is known as Döbereiner Triads. The law given by Newlands is known as the law of octaves. The law given by Mendeleev is known as periodic table. But this periodic table is not the same as the one which is given by Henry Moseley. Therefore, the periodic table given by Henry Moseley is known as modern periodic table. So today we are going to talk about Döbereiner triads. Johann Wolfgang Döbereiner was a German pharmacist and chemist. He worked as a professor in University of Vienna. He successfully classified elements in triads, popularly known as Döbereiner triads. 5.1.1 Döbereiner's triads. In the year 1817 AD, there was a German chemist named Johann Wolfgang Döbereiner. He tried to classify elements with similar properties in a group, means the elements which contain similar properties will be placed in a group. Now the groups presented by Döbereiner had three elements. How many elements were there in the group? Three elements. Therefore, this group of three elements was called triad by him. His idea was simple. The idea was arrange the elements in the ascending order of their atomic mass. Like say for example, one of the triad given by Döbereiner was lithium, sodium and potassium. Let us write down their atomic masses. The atomic mass of lithium is 6.9, that of sodium is 23 and that of potassium is 39. Already you can see that all these three are arranged in the ascending order of their atomic mass. The idea was, if you take the average atomic mass of the first and the last element of the triad, then it should roughly represent the atomic mass of the element which is present in the middle of the triad. Let us check whether the average atomic mass of lithium and potassium resembles to the atomic mass of sodium or not. And if the average mass of these two comes close to 23, then lithium, sodium and potassium will be called a Döbereiner triad. So how to find out the average atomic mass of lithium and potassium? For that purpose, you need to add the atomic mass of lithium, that is 6.9, and potassium, and divide this mass by 2. That is how you find average. The total will be 45.9 divided by 2, which is 22.95 unit. As you know that this 22.95 is approximately 23, which means lithium, sodium and potassium represent a Döbereiner triad. Now let us take three groups and check whether they represent a Döbereiner triad or not. Table 5.1. In this table, we are given three groups, namely Group A, Group B and Group C. We are going to check whether these groups represents Döbereiner triads or not. You know that already. If the atomic mass of the element in the middle of the triad is the average of the atomic mass of remaining two elements, then that is known as Döbereiner triad. Now let us talk about the first group, that is Group A. There are three elements given to you: nitrogen, phosphorus and arsenic. If this would be a Döbereiner triad, then the average atomic mass of nitrogen and arsenic would be near to the atomic mass of phosphorus. For that purpose, we would add up the atomic mass of nitrogen and arsenic. 14 plus 74.9 divided by 2. That would give you 44.45, which is really far away from the atomic mass of phosphorus. What does that mean? That means Group A does not represent Döbereiner triad. As you know the modern periodic table, in the modern periodic table, nitrogen, phosphorus and arsenic, they are a part of group 15. But still, Döbereiner triad rule does not apply to these three elements. That means Döbereiner triads rule would work only in some specific cases. Now let us talk about group B. In group B, there are three elements given: calcium, strontium and barium. If this is Döbereiner triad, then the average mass of calcium and barium would be near to the mass of strontium. For that, the method would be same. Let us add 40.1 and 137.3 and divide that by 2. Here we would get 88.7, which is quite close to 87.6, which happens to be the original mass of strontium. That is, group B represents Döbereiner triad. Let us talk about group C. In the group C, we are given three elements: calcium, chlorine, bromine and iodine. If this is a Döbereiner triad, then the average atomic mass of chlorine and iodine would be near to the mass of bromine, that is 79.9. Let us find out the average mass of chlorine and iodine. Add 35.5 to 126.9 and then divide that by 2. The answer would be 81.2, which is quite near to the actual atomic mass of bromine. That means group C also represents Döbereiner triad. As we have checked, Döbereiner could represent three triads. That is, only 9 elements out of all the elements known in his times, he could classify only 9 elements. That is, first triad is lithium, sodium, potassium. Second triad is calcium, strontium and barium. Third triad is chlorine, bromine and iodine. Even if he could classify only 9 elements, this attempt is considered noteworthy because this was the first effort of its kind. And even in the modern periodic table, you could find lithium, sodium, potassium belonging to group 1, calcium, strontium and barium belonging to group 2, and chlorine, bromine and iodine belonging to group 17. That means the effort made by Döbereiner still holds true in the test of time. But the only limitation is he could classify only 9 elements. Alright, so this would be the first concept for classification, that is Döbereiner triads. In the next lecture, we are going to talk about Newland's law of octaves. Till then, the assignment for you is to write a short note on Döbereiner's triads and also take any 3 elements, consecutive elements from any group of your choice from the modern periodic table from your textbook and check whether they represent Döbereiner triad or not. But for that, remember, you need to make use of atomic mass. Try to check any 2 such groups randomly from the modern periodic table and see whether they follow Döbereiner triad rule or not. Catch you in the next video lecture. Till then, goodbye and stay safe.